We present a set of demonstrations of current work in the Clemson University Virtual Environments Group involving the development and testing of interactive virtual environments for applications in training, rehabilitation, and workforce development. All of these applications are designed to leverage commodity hardware such as HDTVs, game controllers, and the Kinect sensor. The first project is Duck Duck Punch, a stroke rehabilitation game.
Our goal is to improve current arm movement therapy for stroke survivors. Today, rehabilitation for strokes consists of a patient using their impaired arm to reach for an object placed in front of them. This reaching task is performed repeatedly. Given the wide range of limitations to this therapy we discussed in our project outline, we collaborated with stroke therapy experts at the Medical University of South Carolina Stroke Center to create an interactive game using GAC that could improve and extend therapy in exciting new ways. Let's get to the gameplay. In our video, Austin will play the role of a stroke survivor. To play Duck Duck Punch, a stroke patient sits in front of the game and the Kinect and controls a virtual arm with their physical arm. The user reaches out and hits targets with the virtual arm. Here's a closer view of the game with the seascape theme, complete with crab, duck, and seagull targets. A target's point value is based on the difficulty of the reach for someone with impaired movement. Reaching above and below horizontal is harder than reaching straight out, and reaching away from the body is harder than reaching across the body. Additionally, we have two depths of targets. Closer targets have scores that end in 5.
The Rapid Response Training System is designed to help practicing nurses sharpen their observational skills with special attention to helping them learn to recognize patients who are in rapid deterioration. Outcomes for rapidly deteriorating hospital patients are unfavorable unless a nurse recognizes the signs and symptoms and a special rapid response team is called quickly. Our system simulates 4 hospital patients and requires the nurse to monitor their vital signs using instruments in the hospital room, to interact with patients and interpret their behaviors, and to record observations in an electronic health record system. The nurse's goal is to determine which patient is deteriorating.
For our virtual hospital ward with an electronic health record, we created 3D interaction techniques so that the instruments in the hospital room would be easy to use for our target audience, practicing nurses. Our interaction technique is a 3-step process. First, the user can touch or click an instrument to select it. A green halo indicates the instrument is selected. When the user has made their selection, they can touch or click the instrument again, then a menu with the options for that instrument is displayed. Once the user selects an option, the camera automatically zooms in so that the nurse can read the instrument. Then the nurse clicks a button to return back to his or her original viewpoint.
Virtual eSchool for Aviation and Automotive Technology Education. We have developed a set of virtual reality applications for supplementing precision measurement education for technical college students that involves bimanual and unimanual interaction metaphors. The user interacts with the simulation via a 6 degree of freedom electromagnetic tracker with both hands to simulate real-world interaction as opposed to using a mouse. Step-by-step instructions show the user how to manipulate calipers and micrometers, and then they are given an exercise to determine if they have learned the proper technique. We are interested in determining if bimanual psychomotor skills translate to real world better than using a mouse for interaction. Patient safety training in an interactive medical simulation. This complex multi-agent immersive virtual healthcare simulation is used to teach and train clinicians in the Center for Disease Control's 5 moments of hand hygiene. Participants in the simulation act as an infection control specialist and travel throughout the virtual replica of the 4th floor Roy Carver building at the University of Iowa Hospital. The users observe autonomous virtual healthcare workers as they interact with virtual patients and record any infringements of proper hand hygiene that they may observe.